Hello again. So I just want to do a quick video to revisit this problem from 1982, this SAT problem from 1982. Now the original problem was, if you have two circles and circle A here has a radius 1/3 that of circle B, how many revolutions will circle A make as it rolls around circle B? Now some people say 1, some people say 3, some people say 4. I did a previous video on that where I explained why I think the correct answer is 3. But after I did that video, I did another video on the coin paradox where, in explaining what was going on, I realized that I had to invent a new word. And that new word that I invented is a whirlbit. So a whirlbit is defined as a unit of circular motion that represents the combined total of intrinsic rotational spins and orbital revolutions of an object around another object or point. So I started thinking about how that worked in the coin paradox, and then I started thinking about how that works here. So the problem with the SAT question, the reason there's confusion, is because there's two applicable definitions for the word revolution. And then there's something else that happens when we see it revolve 4 times. So the first applicable definition, or the first definition that people are using, is from astronomy. And that is that when an object goes around another object in a curved path one time in an orbit, that was 1 revolution. The second definition is from geometry, and that is when a circle spins 360 degrees around its center. That is 1 revolution. So when we look at the question and we ask which definition should we use, there's nothing in it to indicate that we should use the definition from astronomy. Considering it's a high school SAT question, it's more likely that we're talking about the definition from geometry. So when we ask that question, how many times does A make 360 degree revolutions? How many 360 degree revolutions does A make as it rolls around B? The answer to that is 3. Now, when we get to this problem where we see that the A appears upright 4 times, that's where this whirlbit thing comes in. There's 1, 2, 3, 4. What is happening here? Okay. Well, what's happening is when we view this from our external reference frame, okay, we're seeing A spin around its center 1, 2, 3 times, okay, and we're also seeing it go around B 1 time. So what that gives us is 4 of these whirlbits where the combined total intrinsic number of spins, which is 3, and the number of orbital revolutions, which is 1, makes it look like it gives you these 4 whirlbits. There's 1 whirlbit, there's the second whirlbit, the third whirlbit, and the 4th whirlbit. Now, when I ask myself, what is the answer to the SAT question? And I'm looking at that and I'm saying, okay, does it make sense that we should use the definition from astronomy? Not really. Does it make sense that we should be considering these whirlbits? I mean, these whirlbit things, this is stuff you learn in orbital mechanics. This is stuff you learn in, astrophysics in college. This is not something that the normal, everyday high school kid is going to know. So when I look at, that context and I ask the question, what's the most, relevant answer? And especially considering that these four, I can't even call them revolutions because they're not, it's not a revolution. It's a combination of 270 degrees of spin and 90 degrees of orbital change. That's not a revolution. It's a hybrid. It's a hybrid revolution that I'm calling a whirlbit. And so, when I ask myself, is the answer 1, according to the astronomy definition? There's just no reason to assume that. Is the answer 4, which is these, hybrid revolutions that I'm calling whirlbits, that you see when you learn about orbital mechanics in college? Well, especially also considering that when you look at the SAT question, there's nothing in it that tells us we should be viewing this from an external frame of reference, which is where you have to be in order to see these whirlbits happening. That you observe those from an external frame of reference. And there's nowhere in the SAT question where it says, how many apparent revolutions do you see from your point of view or anything like that. There's nothing like that. It's asking a straightforward question, which I think is they're just using the standard geometry definition, which is how many 360 degree spins does A make around its own center as it rolls around B. And the answer to that is 3. So anyway, that's kind of what I was thinking, and I just wanted to share all that with you, and I hope everybody's having a great day, and take it easy.